Ladies and gentlemen, please welcome Eric Roberge.
Thank you, Todd. Thank you, Todd, for the intro. So I just realized that 18 years minus 25 years, I missed the first 6 years of Intermetric. So not that much. So this morning I'm here to unveil to you guys the new functionalities we've added in PolyWorks 2019, but on the universal metrology platform side. So before to present you all these great new features, I'd like to take 1 minute and discuss about the impact of a universal 3D metrology software for your organization. It all started in 2006, as Mark mentioned in the keynotes, the ambitious project of creating a universal 3D metrology software platform. And at that time, the metrology room looked like this, where each 3D measurement device had their own software. So to run their 3D measurement operations, our customers had two options. Option one, they could train all metrology specialists on all these different software. This option was costly, lots of training costs, maintenance costs, and it also made it difficult for the metrology specialists to become expert on all these different software. There was an option B, and I believe that's what most of our customers did. They split up the team and trained metrology specialists on only one or two software. But this second option also came with lots of issues. The work organization was not flexible. It was difficult to share metrology results, nearly impossible to take an inspection project and reuse it on a different device. Since then, as you know, the PolyWorks Universal Metrology Platform has drastically changed the metrology room, as you now have access to a single software to run all your measurement devices. You have access to a universal workflow, and you have the possibility to create inspection projects, universal inspection projects that can be reused on different devices. And what happens to a metrology team that counts on PolyWorks for all their metrology tasks? Well, the team itself becomes universal. So you can see there are universal teams. These teams, these universal metrology teams, have so much impact on your organization, on the operational costs, that we in Novi need to make sure the PolyWorks universality is progressing in each and every release. And how do we achieve this mission? Well, this is the responsibility of our product management team to ensure that PolyWorks universality is progressing in every release. So to achieve our mission, first of all, we travel every year to meet you guys and discuss about your feature requests, discuss about your different metrology processes, because we care about your success. So in the first part of this presentation, I will present you key feature requests that we have chosen to implement in this 2019 release. In addition to implementing your feature requests, we also have the responsibility to constantly reinvent ourselves and develop the high-impact innovations that will bring your capabilities to the next level. So in the second part of this presentation, you will discover an innovative way to accelerate the development of PolyWorks measurement functionalities. And finally, our product management team needs to stay informed about emerging technologies and new trends in order to develop the new concepts that will benefit you guys over the long term. Have you thought on how the augmented reality devices could impact 3D metrology applications? Well, we did, and we are going to share our vision with you today. So this is the plan for this morning presentation. Let's get started. Just one quick sip. Okay, first topic is GD&T. In 2018, we had a lot of demands for new GD&T tools from customers manufacturing powertrain parts, electrical components, interior panels. These customers needed more GD&T tools. And in parallel to this, the GD&T standards were evolving as well. So in PolyWorks 2019, we have added a lot of new GD&T functionalities. Just one word about the standards. Did you guys know that recently the ASME 14.5 just released the new 2018 edition that was released last February? And the last revision of the ISO GPS 1101 was in 2017. And yes, if you guys know about ISO, there's a lot of documentations. So we had to sit down with the development team and make a solid plan to be able to be compliant with all these new standards. So I'm going to present you now the new functionalities we've added in 2019. This part of the presentation is a bit technical, but that's GD&T, that's the nature of the beast. So, first feature I'd like to present you is the median line. Mechanical parts often have strict functional requirements. And this is the case, for example, on car engine. If you want to inspect, for example, car engine bores, today, if you use PolyWorks to measure the position of these bores, the calculation will be performed using the features measured axes. But in order to support the ISO GPS standard, we needed to develop a new way to measure the position of cylinders using the feature median line instead. This median line is calculated by slicing the data multiple times along the cylinder axis. And that's what we're using now in the ISO mode. We use the median line to calculate position of cylinders, orientation of cylinders as well. So this median line technology also enables us to deliver new functionalities such as the straightness on cylinders again. So straightness is very useful to control cylindrical components like powertrain shafts, for example. Another important tool we've added is the 2-point size tool. To meet the ISO GPS default size requirement, it is necessary to be able to measure the local size of a feature. And this 2-point size tool will allow you to do that. This method consists in measuring multiple times 2 points diameters along the full feature length. And from all these measured values, we can find critical information such as the shaft's weakest point. With all these measured values that are calculated with the 2-point size, to benefit of all these values, the ISO GPS offers size modifiers, such as the average size, the minimum size, and the maximum size modifiers. So those are modifiers you can find on drawings. So we support these. And finally, we're going to add global size modifiers as well, and those ones will be available in IR1 next month. Global size modifier will allow you to specify how you want the controlled feature to be fitted prior to calculating the GD&T. So we will deliver the maximum inscribed modifier, GX. We have the minimum circumscribed, the GN modifier. Gaussian means best fit, GG. And the last one is called Chebyshev, GC modifier. Another name for that one is mini-max. It's the min and max fit, the mid circle between the min and the max circles. So that sums up the additions we made for the GD&T toolbox. We're going to add more in the upcoming intermediate releases. So let's jump onto our next topic, manufacturing feedback. You guys know how important it is to communicate metrology information to your manufacturing team. It's important to communicate the metrology results, and one of the main reasons is that it provides important information to the manufacturing team to understand the quality of the parts they produce, and also to find the corrective actions that needs to be applied if the part is deviated. So for this reason, we are constantly improving our reporting and our reviewing tools. And if we take a minute to look at our different reporting and reviewing tools in PolyWorks, we can classify our different tools in 4 different levels. You will see what I mean here. Level 1, you report results using tables. So we know a lot of you guys are using tables. It's a good way to share metrology information. Level 2 adds some visual to the tables by complementing the information with images. So color maps, annotations. These visuals give more information. It eases the understanding of the part defects. We added level 3 in PolyWorks 2017 when we developed the control views. So using control views, you can now review in full 3D metrology results, and you can see controls in their appropriate manufacturing context. Level 4 is interesting. With the emerging augmented reality technologies, it is possible now to review metrology results on the real part. So you can see information superimposed with the real object. We're going to talk about that at the end of this presentation. So for those of you who report metrology results using tables, images, and fill corporate spreadsheets using Excel, you'll be pleased to know that we are introducing a new product, the report loop for Excel solution. So don't miss the report loop for Excel presentation this afternoon. We'll discuss about that. Now on the control view side, we have developed a new intuitive way to create control views. You can now display only the objects that you want to add to a control view and orient the scene and directly create a control view that matches exactly what you see on screen. So this is a new intuitive method. And with this new method, creating control views is as easy as taking a snapshot of the 3D scene. So we just created 2 control views, and we're going to open the reviewer to look at the 2 views quickly. That's view 1 and view 2. On the control view editing side, we have also worked on this aspect. So you will be able to add control to or remove control from an existing control view. This development will be finalized in IR2 in June. On the reviewing side, we've also added important new capabilities. You'll be able now to display deviation vectors. So deviation vectors on points reducible features, so to ease the reporting of positional deviations. You can now create custom properties on controls. So a person who reviews an inspection can create specific notes for a specific person in the organization, like a note for the machinist or a note for the designer. Finally, we've added an easy way to display the min and the max deviation points annotation. So those min and max points are very important when controlling profiles, surface deviations. So that concludes the additions we made to the reporting and reviewing of PolyWorks 2019. Let's jump to the main topic now. This is probably the biggest innovation we have introduced in the Universal Metrology platform. Due to the rapid expansion of our PolyWorks sales and the evolution of your needs, we were bombarded by demands for new measurement methods. We have received lots of demands for specific measurement methods. And often these methods were very specific. So one client wanted specific methods for one particular application. So there was a lot of requests, so we could not develop all these methods. It would take years. So I'm pleased to announce today that we have found a way to accelerate the development of PolyWorks measurement methods by allowing you to integrate scripted measurement methods within the standard PolyWorks workflow. You will understand what I mean in the next couple of slides. To give you an example, we have scripted three measurement methods, and integrated them into the standard PolyWorks. So you will discover that you can use those scripted methods as easily as if it was a standard measurement method like probing or extraction on scan data. So we recorded a short video, and the video will present three methods. The first scripted method is a generic one-point probing method. The second one, it's a probing method that allows you to find the max point on a plane. And in the last scripted method, you'll see a depth measurement using a digital caliper. So all those methods were scripted and integrated into PolyWorks. Let's see how this works. So what we're seeing here is the first method, one-point probing. So with this method, the operator can probe hole positions by acquiring only 1 point at the hole center. There is no need to probe constraining plane. And the method is perfectly generic as it supports all types of holes, circles, squares, polygons. In the second method, we'll find the max point on a plane. So first, the operator can probe the plane as usual. So that's a standard plane probing. But then the script will give feedback on the screen so you can view the highest point location. And the script allows you to refine the probing by measuring with a higher resolution. And the goal here is to find a more precise location of the max point. Finally, in the last example, we'll see how a digital caliper can now be used interactively as if it was a device for which PolyWorks offer a plugin. Measuring a new piece is easy as the play inspection technology supports these new scripted methods. So what we've seen in this video is that this technology will allow you to integrate any digital devices in your standard PolyWorks environment. Think about digital calipers, LMI gauges, roughness gauges, flush and gap gauges. So all these digital devices can be integrated within PolyWorks. We also saw that with this technology, you can expand, you can create your own set of measurement methods and integrate it inside the standard menus. And finally, we saw at the end of the video that those scripted methods are perfectly integrated within the play inspection workflow. A big question, can we go further with that? Can we use this technology on point cloud data? I know a lot of you guys are using point clouds with PolyWorks. So can we use this technology to develop new measurement methods applicable to point cloud data? To answer that question, I'd like to invite on stage my colleague, Travis, for a short demonstration. Travis?
Thank you, Eric.
So I'll give you this. Yes. I'll keep my bottle.
Yeah. Thank you, Eric. One of our customers came to us last year with this interesting challenge. This interior car panel needs to be inspected via scanning. And for context, the blue clip is holding the orange or the gray panel into the orange panel. And the task is to measure the post on the gray panel, specifically the position to ensure that it fits within this rectangular opening. The engineering drawing for the gray panel calls out the hypothetical rectangular opening, which can be reduced down to a center point. One way to determine this center point would be to create small planes on all the contact surfaces and then use constructed features to derive the center point. The first issue we encounter with this method is that constructing all of these planes and constructed features is very time consuming. In addition to the complex setup, extracting these features is problematic. The planes are very small, and with surfaces this small, extractions can become an issue. And if one plane fails to extract, we can no longer report the dependent center point. So in production, we end up spending a significant amount of time troubleshooting extraction parameters. Probing is not an option due to the small size of the planes and other process requirements. So what about using a different technique? If we replace all the small planes with surface features, extraction becomes much more robust, and we're left with the task of determining the X and Z position of the center points. So let's take a look at the part. I have here the CAD model of the part, some center points as defined by the engineering drawing, some surface features representing the regions of interest, and some scan data. And as I said, the task is to populate those X and Z values of the center points. Before we do that, I'd like to look at how X, Y, and Z are traditionally defined on a conventionally extracted feature, such as the circle at the top of this post. So that nominal circle is defined by the CAD model. We import or measure some scan data, and we use that nominal circle to select some measured data in the region. To that measured data, we fit a measured circle And once we have the nominal and the measured circle, we can determine the x, y, and z deviations of that circle. We can also do some things like align the circle using best fit measurement objects in this case. And now we have 0 deviations on x, y, and z. We're aligned to the circle, and perhaps more importantly, the measured circle moved with the measured data, and they're now sitting on top of the nominal feature in the CAD model. So this is the behavior we want to see from those center points. So we'll take those center points there. We want the center point, the measured center point, to move with the data object. We want the center point to read 0 when we're locally aligned to that post. So let's start by measuring the post. I'll use an extraction group for this to account for any large deviations. And once we have it measured, we can select the data that belongs to it. At this point, we can align to it using those selected points and a best fit without any pre-alignment. So now we're locally aligned to this post. And at this point, I would like my center points to have a 0 deviation. So we can define the measured value. Another way to say that is I would like my measured value to equal my nominal value. So at this point, we have our 0 deviations. The one remaining task is that since we manually define that, I need to manually bind it. At this point, we can return to our global alignment, and now we have the deviations for that post. So if I needed to do this for this one part, I could carry out that manual method for the remaining 2 posts. If I needed to do this in production, however, it's worth noting that I used the manual selection method, so PlayInspect would not work with this sequence. I should really consider writing a script. And if I write a script for production, it needs to account for all the variables that I'd encounter in production, and at some point it starts to replace rather than augment PlayInspect. And this is where the scripted measurement method becomes so powerful. Rather than writing a complex script that replaces PlayInspect, I can write a small targeted script that closely mirrors those steps we just walked through. So I already have that script available. Let's take a look at how we can apply that to these points. I need to start by clearing my work here. And let's show these. So just as if I were defining a measurement method, I can go down to Properties in my Measurement tab. Like I was setting my extraction parameters or probing parameters, I can now specify a script. I don't have my script loaded yet, so I'll select More. This brings up our new macro script manager, and from here I can import a script. Note that on the right, it opened up a few parameters. I created these at the time I wrote the script. This provides operators a way to interact with the script without having to edit it. And from this dialog, I can also save the script to my user configuration. Now that it's in my user configuration, I can push this, as well as any other library of scripts, to other users by pushing a user configuration. Now that I have my script loaded, I can select it, apply it, do whatever work I need to do, and when it comes time to measure these center points, throw a right-click, just as I would probe measured or extract measured, I can run my script on all 3 points. All right. So now that I'm done with that inspection, it's a good time to report it. And this is a good time to show off some of our new reporting tools, such as our center point deviations and our create control view from objects in the 3D scene. Create a report at the same time. We have our image and table. And now, if I need to do this again in the future, I should create a sequence so that myself and my colleagues can rerun this a few days or weeks down the road. Note that these surface points, center points are calling the macro script I specified in the sequence. So that's all perfect. I can save it. And when it comes time to run the next piece, I can do as I'm used to and click New Piece, launch PlayInspect, measure or import some data. And PlayInspect will trigger that macro script at the appropriate time without me having to insert any new lines of code. So that's it. We finished our second piece. And I'd like to point out that because we used a generic surface feature to do this measurement, I can apply this script to posts that look like this, or just as easily, I can apply it to posts without any side ribs, for example. I'm not dependent on a particular configuration or arrangement of planes. And perhaps more to the point, the next time I encounter a similar requirement, such as the center point on these rounded slots with complex draft angles, I can apply the same technique through a right click. Because it's in my user configuration, it's accessible and usable right here. So just to review, I applied a small targeted script to some feature points, and because the script was applied as a measurement method, I was able to easily integrate it into PlayInspect without any extra lines of code. And because the scripts were stored in my user configuration, I was able to easily access and reuse this script the next time a similar requirement came up. So that concludes our first example. Next, I'd like to look at some laser tracker examples. Many tracker operators use PolyWorks to measure fixtures and jigs. These laser tracker operators are generally well equipped in terms of their accessories. Many of these accessories are already supported within PolyWorks. However, some are not, such as the extension bar or sphere fit bar on the right, or the vector target or vector bar on the left. Using the scripted measurement methods, laser tracker operators can now benefit from a seamless integration of these accessories. In this example, the operator is measuring a small aircraft wing using a standard reflector. When the time comes to measure the sidewall, he finds that it's not easily accessible from the current position. The operator can use an accessory known as a sphere fit bar to measure beyond the line of sight. The sphere fit bar is now perfectly integrated into the PolyWorks environment and accessible through a right click, just as we would define other measurement methods. For those who are not familiar with the sphere fit bar, the operator holds the tip stationary and moves the reflector about that point to generate a spherical point cloud. At this point, the measurement script takes over and fits a sphere to the spherical point cloud. And the center point is converted to a probe data point. As a result, the final plane is effectively probed and compatible with all of our standard analysis tools. Here's another example. To automate the measurement of hole position and orientation, a vector target or vector bar can be used. The vector bars have a known offset and specific pin diameter for measuring holes of a specific size. In this case, we'll be using 2 reflectors to speed up the measurement. The vector bar method is integrated into the standard menus, and the operator selects the desired features, specifies that they'll be measured with this method. Once inserted into the hole, the vector bar and reflectors are stable, so the measurement script can drive the beam to the reflectors. The macro script sets the feature diameter based on the vector bar parameters and calculates the orientation and position from the reflector readings. The operator is using PolyWorks Talisman, our mobile app, to trigger the next measurement. And the next time this jig needs to be measured, PlayInspect can be used, and the vector bar method will be automatically triggered at the appropriate time. So with that, I'll hand it back to Eric.
Thanks, Eric. Good job. Okay, thank you, Travis, for these great examples of using laser scanners and scan data. So what is clear is this new technology will simplify the use of PolyWorks through the entire manufacturing process, whether you're using PolyWorks for product engineering or part certification or production. If you're using PolyWorks or planning to use PolyWorks in production, this is definitely where this technology will have the biggest impact. And Mark mentioned it a little bit in the keynotes. Production Metrology in production have specific requirements, very structured requirements. Each production environment has their own sets of measurement methods that are often well documented and standardized. You also need to use a wide variety of devices in a production environment. And those devices sometimes are very different than the one used in pre-production. And finally, when measuring data in production, the acquisition process has to be robust. The operators must be guided, and the metrology system must be able to handle any problematic situations. So for all these reasons, customers who successfully deployed PolyWorks in production have traditionally relied on creating those large macro scripts. That approach works. It works, but it has important limitations. When running those large scripts, you cannot use the play inspection functionality. You cannot use measurement sequence. It's difficult to reuse a script like this and apply it on a different project. It is also costly to maintain and difficult to maintain. So PolyWorks 2019 will put an end to those large macro scripts, as you will now be able to embed your production requirements within the measurement objects and rely on the standard play inspection functionality. You will be able to create libraries of customized measurement methods and share them through your organization. At this point, I'd like to take a couple of minutes and invite on stage one of our customers who had the opportunity to beta test PolyWorks 2019 on the production floor. Please welcome Mr. Jean-François Caron from Bombardier Aerospace. Sorry. Jean-François?
Thank you, Eric.
Jean-François, can I call you Jeff for the...
No problem.
Yes?
That's
Okay.
for sure.
So, easy question to start. Tell us a little bit what you do at Bombardier and where do you use PolyWorks today?
I am a manufacturing engineer in Bombardier Aerospace at the Challengers plants located in Montreal, Quebec, Canada. So we assemble the Challengers 350 and 650, which are businesses aircrafts. So we already have PolyWorks in different departments, such as tooling, quality, and production departments.
Jeff, do you have an image of the Challenger?
Yes.
Okay.
Here's a 350. So we run also PolyWorks in production with on stations in 2 stations as of today. So here we have one production station that we adjust the wings flight controls with one laser tracker and PolyWorks. We have a second station where we adjust the aircraft's flight instrumentations and the tail's flight control running also PolyWorks and one laser tracker. And we are working now on implementing a third production station to join the fuselage with 2 laser trackers.
Yeah. So that's the station you're currently working on, and that's where you have tested PolyWorks 2019, isn't it?
Yes, you are right. So this station is used to join the forward and the aft fuselage at the same time with the mid fuselage that is static. So we need to deploy a program to guide the operator to manage the laser trackers and PolyWorks, even if they are not used to operate these machines and software. So we need a robust program, and we need to manage all the potential errors that can occur during the joining. So to achieve that, we created a large macro in PolyWorks 2018 in the last few months. And like you said, we had the opportunity to beta test 2019 a month ago.
Okay.
To see what is the benefit with what you just explained earlier.
Okay. Go to the next slide, Jeff. I think we'll see, yes.
Yes.
This image. We have a better view here. We see the two trackers on each side, and we see all the targets on the fuselage.
Yeah, so we have custom targets on all the fuselage and the critical features. So we created a new program with 2019 version of PolyWorks to simplify the large macro script with sequences and object measurement script. So with this, to give you an example, the large macro script from 2018 was reduced to 6 sequences and 1 object measurement script to have an automated solution that meet all our requirements.
Okay. So it's not only the object measurement script that was the key here, is also the use of sequences, measurement sequences.
Yes, you are right.
You have an example of this, I think, on the... Yeah.
Yes. So by using the sequences and the object measurement script, it simplified a lot the learning and also the maintenance of the program over a long time in production. And also the object measurement script and the sequences are modular. So we can reuse the exact same object measurement script or sequence in different projects, different departments, and ultimately different plants in our own organization.
So anything else you'd like to add to this?
Yes. I'd like to mention that we wanted to deploy with PolyWorks 2018 initially, but with all the benefit we've seen on last months, we are not moving forward to implement with 2019 in the next few months.
Nice. Okay.
So thank you very much.
Thank you. Thank you for sharing this with us.
Thanks.
Okay, so what we saw in the last part of the presentation is that you will now have the possibility to create your own measurement methods and integrate it into PolyWorks. You'll be able to create reusable measurement building blocks and share these building blocks with your colleagues. And finally, we believe that this new technology will simplify a lot the maintenance process, as the core of your inspection in production will rely on the standard play inspection. I'd like to share one good news with you. Most of the measurement methods that we presented today, the scripted measurement methods, will be delivered standard with PolyWorks 2019. So you can install PolyWorks 2019 today, and you can start using those methods. Now the time to talk about emerging technologies. This year, we want to introduce you to the tremendous potential of augmented reality in our metrology field. We believe so much in AR that we decided to create a new product. So I'm pleased to announce today that we are adding to our PolyWorks metrology suite a new PolyWorks AR solution for Microsoft HoloLens. This new product will be delivered next month. And you will see in the next video what you will be able to do with the version 1.0. So first, we start a PolyWorks app on the AR device. Then we select and open an inspector project. The first step to do is to snap a CAD model view to the real object. Then we can start displaying the nice graphics on the real object. This is a data to reference color map superimposed with the part. We have a toolbar that is accessible in the field of view, so you can activate and deactivate buttons with a gesture. Here's another example on a manifold. The user can add color map annotation points using the cursor and the gesture that we used earlier with the toolbar buttons. What do you guys think of this? You want to start doing this? So if you want to start doing this, you'll have to purchase a Microsoft HoloLens. I don't know the exact cost, but this device has very unique characteristics. It comes with powerful onboard computer. It has the possibility, it can display, of course, the graphics, the nice holographic images. This device also has a Kinect 3D scanner, so it can scan the environment. And it has all the 3D axis sensors needed to track the user displacement, and that's very important. To be able to use this technology for metrology application, it is important to be able to localize the AR device with the real part. Otherwise, all the display would be at the wrong location. So let me take a minute and explain to you how is this localization process is done. First of all, we're using a technology called model-based tracking to snap the CAD model view to the real object. Once this is done, we can display the nice graphics. The good thing about model-based tracking is that it does not require to use targets. There is no need to put targets on the part. You can start using the HoloLens directly without having to prepare the part. But model-based tracking also has a limitation. It works well if you can see the entire part, if the camera can see the entire part. It can be an issue if you are looking at a very large object and the camera do not see any characteristics, any feature lines. So for this reason, we are using a second technology to be able to track the user displacement. We're using the HoloLens SLAM technology that continuously track the user displacement and update the localization. So it's a combination of two technologies we're using. So what you just saw in the AR video is just a start. Our PolyWorks AR solution will evolve rapidly in PolyWorks in this year. In the short-term plan, we want to offer the possibility to display object annotations, so you can review annotations on the real part. We want to allow simultaneous connections, so two colleagues can review metrology results together on the object. On the longer term, we want to offer guidance for probing and scanning applications. We want to display digital readouts to guide, for example, build and spec applications. And we want to offer you all the necessary tools that you need when you are far away from the computer. Microsoft has recently announced the release of the HoloLens 2. So HoloLens 2 will come with a complete gesture recognition capabilities. So we will also integrate those gesture capabilities as well. So with the arrival of a new product like PolyWorks AR comes the necessity to revisit our packaging strategy. So you guys know our real-time meshing technology. This technology was introduced in PolyWorks 2014, and it has rapidly become the standard way to laser scan a part for industrial applications. So we needed to make room in our Inspector Premium package for the new technologies. So we decided to offer the real-time meshing technology in our Inspector Standard package. So if you currently own a license of PolyWorks Inspector Standard, and if you are entitled to a 2019 upgrade, you will get the real-time meshing at no extra cost. Also, we decided to boost our Inspector Premium package with two great additions. First of all, you see where I'm going. PolyWorks AR will be included in the Inspector Premium. And the second thing, we are adding a new PolyWorks Modeler Lite module to provide you with the basic polygonal editing functionalities, such as hole filling, smoothing, polygonal reduction. So Modeler Lite will be included in Inspector Premium. So again, if you own a license of Inspector Premium, and if you are entitled to a 2019 upgrade, you will get PolyWorks AR and this new Modeler Lite module at no extra cost. So I believe that's a good news, isn't it? So I'd like to invite now my colleague Richard and Mark for the question period. And we'll have a short conclusion after that.